So, have you ever really thought about what it takes to teach a machine how to see? I don't just mean record pixels like a camera, but to actually understand the visual world, kind of like we do. Let's dive into the fascinating science of computer vision.
But first, I want to show you something a little strange, something that comes directly from the mind of an AI.
All right, so here are two super simple, distinct concepts, right? On the left, a nice warm cup of coffee. On the right, a cute, fluffy cat. Our brains get both of these in an instant, no problem.
But what happens when you ask an AI to merge these two ideas together? What does it imagine?
You get this. A cup of cat. It's whimsical, it's weird, and yeah, it's a little bit magical. This creative, almost dreamlike ability is the result of decades of intense research into making machines see.
To really understand how we got here, we first have to get our heads around the fundamental challenge. For computers, seeing isn't easy at all. In fact, it's incredibly hard.
And this slide really shows you why. When we look at an image, like this blurry eye on the left, we see a shape, an object, an eye. But a computer gets what you see on the right, just a massive grid of numbers. Each number is just a pixel value. For the machine, there's no meaning, no eye, just raw data.
And this is one of my favorite illusions, because it shows that our own vision is so much more than just measuring light. Take a look at squares A and B. You'd swear that B is way lighter, right? Well, in reality, they are the exact same shade of gray. I'm not kidding. Our brain is automatically interpreting the whole scene. It's accounting for the shadow from that cylinder. It's making an inference, not just a measurement. And that's the trick we need to teach computers.
You know, the pioneering vision scientist David Marr put it perfectly. The ultimate goal for us and for machines isn't just to look, but to know, to find that meaning in all that visual data.
This whole quest for meaning has been a long and difficult journey, and it's one that started with some, let's call it charming overconfidence. Okay, get this. This is a memo from MIT back in 1966. It outlined something called the Summer Vision Project, which was an attempt to basically solve the entire problem of computer vision in a single summer. Yep, they thought a few months would be enough. It just shows how massively they underestimated the challenge.
And this timeline, it tells the real story. After those super optimistic projects in the 60s, progress was slow, for decades. Then in 2001, we got the first real-time face detection, which was a big deal. But the true revolution, the earthquake, came in 2012. A model called AlexNet, using a technique called deep learning, just absolutely smashed all the previous records. That moment kicked off the modern AI era and paved the way for the incredible models we have today.
So after that long, difficult journey, we've finally arrived. We're at a point where this technology is unlocking applications that are changing our world in some really profound ways.
I mean, look at healthcare. AI vision systems can analyze medical scans and spot patterns of disease that are sometimes invisible even to a trained doctor. We're talking about diagnosing conditions earlier, helping to save lives. It's incredible.
Or in robotics, where vision lets a machine understand and interact with the physical world. It's how a robot can assemble a car on a factory line or even carefully chop a cucumber for a salad.
And of course, it's the core technology behind autonomous vehicles. These cars are just packed with cameras that act as their eyes, constantly identifying pedestrians, other cars, and traffic lanes to navigate the world safely. And computer vision even helps protect our planet. These systems can automatically track animal populations from camera footage, giving conservationists vital data to help protect endangered species and entire ecosystems.
But with all this incredible power comes an enormous responsibility. The final, and maybe the most important test for computer vision isn't just about seeing accurately, it's about seeing fairly. Here's the thing. These systems learn from data that we humans create, and that means they can inherit our flaws, our societal biases. A computer's vision isn't automatically neutral. So how does this happen? Well, it's pretty simple, actually. AI models learn by finding patterns in the massive data sets they're trained on. So if that data is biased, for example, if it underrepresents certain groups of people or certain cultures, the AI will learn and amplify those biases. That leads to unfair or just plain inaccurate results.
And this isn't just a theory. Studies have shown that object recognition systems trained mostly on images from high-income Western households perform significantly worse when they have to identify everyday items from other parts of the world. They just haven't seen enough examples of something like a clay pot or a charcoal stove to recognize them reliably.
And that brings us to the most critical question we face today. For 60 years, the whole challenge was just teaching a machine to see. Now that they finally can, the new challenge is this. How do we ensure they see the world, and everyone in it, with fairness and equity? That's the problem we all have to solve next.